Okay. Okay, now in continuation with the Hagen Poiseullis equation, we are going to see a problem. So problem is, in a pipe of 300 diameter, the maximum velocity of flow is found to be 2 meter per second. If the flow in pipe is laminar, find the average velocity and radius at which it occurs and the velocity at 50 for wall of the pipe. So here we are given maximum velocity. So it is U max is equal to 2 meters per second. A diameter of pipe is given to us 0.3 meters. So let us, we have been asked to find out the average velocity and radius at which it occurs. So average velocity u bar is equal to half u max. We have already seen in the derivation. So directly putting half into 2, 1 meter per second. And at what radius it occurs. So for this we can use the formula of u directly. So u is equal to u max 1 minus r small r upon capital R whole square in the derivation we have seen. So when u is equal to u bar, we can find out what is r. So if we take, instead of u can be any u, it may be u average also. So if I take u average, I have to find out at what radius it occurs basically. So instead of u, I'll put 1, which is u average. U max value is known to me, which is 2. 1 minus r upon capital R is the radius of the pipe. So diameter is 0.3 meter, so its radius is 0.15 meter. The whole square. So small r becomes 0.106 meter. Then secondly, we were asked the velocity at 50 for the wall of the pipe. So we have to find out u velocity at 50 from the wall of the pipe. So again using the same equation, u is equal to u max 1 minus r upon r square whole square. So here we are given r of pipe is 0.15 meter and small r is, now what would be the small r? Small r is radius from the center of the pipe where this velocity occurs. So small r is capital R minus 0.5, which is the distance from the wall. So ye u will occur here at a distance of 50 from the pipe wall. So r is from the center of the pipe. So r becomes, small r becomes capital R minus 0.05. So it is 0.1 meters. So putting in the equation of u, I'll get u is equal to u max 2, which is equal to 2, 1 minus 0.1 upon 0.15 whole square. So I'll get the velocity, which is 1.11 meters per second. Let us see one more problem. Yes, so this is the problem. So the problem says a lubricating oil of viscosity 1 poise and specific gravity 0.9 is pumped through a 30 diameter pipe. If the pressure drop per meter length of pipe is 20 kilonewton per meter square, determine the mass flow rate in kg per minute, the shear stress at the pipe wall. So flow rate is Q, but we have to find out mass flow rate, and shear stress is tau. So now the given things are mu, which is the viscosity is 1 poise, so it is 1 into 10 to the power minus 1 Newton second per meter square. Then specific gravity is 0.9, diameter of pipe is 0.03 meter, length of pipe is 1 meter. I have to find out the mass flow rate. So mass flow rate Q, or we can say flow rate Q, is equal to area into velocity. Area can be known by pi by 4 d square. Velocity can be found out by the Hagen Poiseullis equation. So Hagen Poiseullis equation says P1 minus P2 is equal to 32 mu u bar L upon d square. The pressure drop is given to us as 20 kilonewton per meter square. So pressure drop is nothing but P1 minus P2. So P1 minus P2 is 20 into 10 to the power 3 Newton per meter square. So putting all the values in Hagen Poiseullis equation, I'll get U bar or U average is P1 minus P2 into D square. So P1 minus P2 is 20 into 10 to the power 3 into P square is 0.03 square upon 32 mu L. So 32 into mu is 0.1, length of pipe is 1. So average velocity is 5.625 meter per second. So flow rate Q is equal to area into velocity. So area is pi by 4 d square into velocity. So I get 0.039 meter cube per second. Mass flow rate is nothing but it is the mass density into the discharge or flow rate. So 900 is the mass density. It is given to us. That is gravity, specific gravity is given to us 0.9. So mass density becomes 900 into 0.003975. So it becomes 3.577 kg per second, or in kg per minute it will become, let us multiply it with 60 seconds is equal to 1 minute. So 3.577 into 60, which is equal to 214.65 kg per minute. Similarly, shear stress at the wall, tau 0. Second thing we had to find out, tau 0. So tau 0 definition is minus del P by del X R by 2. Now minus sign is there because pressure decreases in the direction of the flow. But while finding out the values, we are not going to put minus. So del P by del X is P1 minus P2. So P1 minus P2 is 20 into 10 to the power 3 into R. Radius is diameter divided by 2 upon 2. So diameter is 0.03 divided by 2 upon 2. So I'll get shear stress is equal to 150 Newton per meter square. So dear students, by these using these equations while deriving, we have seen for shear stress, for velocities, three types of velocities, that is u max, u average and only u. And using Hagen Poiseullis equation, we can find out the velocities also, we can find out the pressure drop also, and we can find out the shear stress also. I hope now your doubts regarding laminar flow and its application and finding velocities and shear stress are now will now be over. Thank you very much for listening to me.